My name is Janet Montgomery. I'm an archaeological scientist at Durham University, and the topic of my research area is isotope analysis of humans and animals. And this is a method that we use to get information directly from archaeological humans and animals about aspects of their life, such as where they were born, how they moved around the landscape, if they migrated from one region to another, how their diet might have changed over their lifetime and what they were eating, the types of food they ate, how much protein they had, whether they were eating marine foods or foods from the land, such as pork, beef, lamb, grains that were grown on land, and also things like how much pollution they were exposed to whilst they were growing up. So if they were living in an urban environment that might have been subject to quite a bit of atmospheric or other types of pollution, or a rural environment which might have been much more natural and pristine. And these techniques allow us to find out information about people in the past that we can't actually get any other way. They're quite recent and we're still developing them, but at some sites and in some periods they give us some very useful information about humans in the past. So we've been applying these techniques to the burials at Driffield Terrace in York for over 10 years now, and they have given us some really interesting information about how diverse the population at Driffield Terrace was, and some indications about what sort of places they may have come from in the past. So we've used things like strontium isotopes. That gives us information about the type of geology that the individual was living in and sourcing their food from. So if they move from one type of geological terrain to a different one, so for example if they moved from a granitic terrain to a chalk terrain, we can spot that in their teeth. And that's shown us that there's a lot of the individuals buried at York are not from York. They've come from elsewhere, possibly in Britain, even further afield. We've also used techniques like oxygen isotopes. This gives us an indication of what the climate was like in the place where the individual grew up. So if they've moved from a hot climate to a cold climate, we can spot that. And again, at Driffield Terrace, we have some really interesting information. We have people there that have come from much colder climates than York, and also from much hotter, warmer climates than York. We also have information from their diets. So again, if people have changed their diet radically, or they've moved from a place where types of foods were available that weren't available in Roman York, we can spot that as well. And we have individuals in York who were eating what we call C4 crops. So these are types of grains like millet and sorghum that weren't present in Roman Britain. And we have people at York who had been consuming these foods, and so we can assume from that they were eating them elsewhere and have moved to York subsequently. So more recently, we combined these isotopic techniques, which are very good at giving us information about the people who did the moving. So they only really work with that colonizing, migrating generation. They don't work with their descendants, but things like ancient DNA do. So ancient DNA gives you information about the genetic ancestry of the person. Not that necessarily they moved, but that their ancestors sometimes in the past have moved. So at York, we combined these two techniques more recently on a group of 7 individuals from Driffield Terrace. And I did the isotope analysis on these, and most of them came back quite normal, what we would expect within the bounds of what we would expect for Roman York. But one individual had a very odd oxygen isotope ratio, and this was off the scale really of anything that we'd obtained from Britain before. It was way too hot, the value that came back. So we measured it again and again. We replicated it 3 times, trying to find out if it was something wrong with the analysis or whatever. And then it came back the same every time. So then after that, I had to go to a meeting where we met with the DNA people and various other people from working on the project to put the data together. And I was a bit worried about this because I thought there was possibly something wrong with the analysis. But anyways, it turned out the ancient DNA showed that 6 of the individuals had genetic ancestry consistent with Iron Age Britain, so Britain before the Romans arrived, but one individual didn't, and his genetic ancestry appeared to come from the eastern Mediterranean, so Syria, Lebanon, Jordan, that area, and it was the individual that we had the really unusual oxygen isotope ratio for. So the two types of evidence agreed. So it was a big relief, one, that the techniques actually worked, and two, that the analysis showed that not only had this individual got genetic ancestry from this part of the world, but also that he'd actually done the moving. So he'd moved from somewhere very warm and southerly to York, and so that it picked out the person doing the migration, and also that they had genetic ancestry that was not normal for Roman York at the time. Another type of analysis that has worked very well at Driffield Terrace is looking at lead isotopes, and also not just the isotope ratio, but the amount of lead that individuals there were exposed to when they were children. And we do that by looking at the amount of lead in the tooth enamel, which forms during childhood, and then it doesn't subsequently alter. So it's like a little time capsule that remains with the individuals wherever they subsequently move. So we're looking at the lead isotopes, which gives us an indication of the type of lead, the source of lead, where it was coming from, where they were obtaining their lead from, and also the amount of lead. And the interesting thing about the Roman period is that before the Romans arrived in Britain, most people, in fact almost everybody we've looked at so far, had very, very low levels of lead. So this was lead that was coming from natural sources just by ingesting soil particles or hand-to-mouth activity in children, that sort of thing. But once the Romans arrived, they start mining lead in huge quantities that didn't happen before, and they were extracting it from mines such as Charterhouse in the southwest of England, the Peak District, the Pennines, and then not just using it in Britain, but exporting it all over Europe, because they had a huge demand for lead, and not just the lead but the silver, because often lead and silver are found together. So they would cupel the silver out of the lead, and then they would use the lead for other things. And they used, everybody knows that the Romans used lead for water pipes and water storage containers. They would keep their wine in it because the lead would react with the wine and produce lead acetate, which is a very cheap sweetener. So it's called sugar of lead. So they used that, and also they would cook things in lead pans again because it would sweeten the food and produce condiments and various things. They also, so for the first time, the Romans were making compounds out of the lead acetates, lead carbonates, and this makes it a lot more what we call bioavailable. It's a lot more easy for the body to absorb and ingest the lead. So this is the first time, and what we see in the Roman period is a huge increase in the amount of lead that people were exposed to. So this gives us, so we use the lead, in the past it used to work in the same way as strontium, so it was giving you an indication of the geology, but once the Romans arrive, it's basically telling us more about the cultural sphere that people were occupying and what they were doing with the lead and where they were getting their lead from. So in the Roman period, almost everybody has English lead. Almost everybody we've looked at, apart from very few individuals, and those are mostly at Driffield Terrace. We have several individuals from Driffield Terrace who were exposed to lead sources during childhood that are not consistent with those from England. So they would have been exposed to this somewhere else, possibly in the Mediterranean region, because the lead, most of the lead from these individuals is coming from much younger sources than we have in England. So we can spot that very easily, and not only do these individuals have a different source of lead, but they also have a lot more lead than the normal people in England before the Romans arrived would have had. So it works very well in these situations, and we've not only does the lead show us that they weren't exposed to sources of lead, but then other types of evidence, such as the individuals that were eating C4 crops that weren't present in England also have lead that isn't from England. The individuals with very cold or very warm oxygen isotopes also have lead. So the types of techniques that we use build up, they layer up and produce a very strong evidence that these people are not born and raised in Britain, but have come to Britain from other parts of the Roman Empire.